Okay, so what I want to do in this video is analyze cosine's graph in order to sketch a graph of secant. And then once we get the hang of how that works, it's actually pretty easy to sketch the cosecant graph. Um, so cosine is already graphed right in front of us, and secant we can analyze cosine in order to get secant because they're directly related, since secant is 1 over cosine. So let's take a look at some of the important pieces of the cosine graph. We've got the peaks, we've got the valleys, and we've got the zeros here. So the first thing I want to do is, why don't we look at the zeros? So cosine is 0, for example, at 3 pi over negative 2, or negative 3 pi over 2. Well, whenever cosine's 0, secant is going to get messed up, right? Because then it's 1 over 0 that I'm figuring out here, which is undefined. On the graph of secant, it won't be defined anywhere that cosine is 0. So that means that the picture that we're going to get is going to be, well, it's going to be undefined, so there will be something weird going on with this graph, and we learned that a lot of times when it doesn't cancel, with anything in the numerator, that's where we get these vertical asymptotes. So I'm going to draw in these. We're just going to draw the graph of secant right on top of the graph of cosine. So everywhere that there was a 0 for cosine, now there's an asymptote for secant. Okay, so now we've got this. All right, next thing, let's look at the peaks. So the peaks are all at 1. The y value is 1. The cosine value is 1 there. So let's take a look at what happens to secant when cosine equals 1. Right? So if cosine is 1, for some x value, for whatever x value really, if cosine of x equals 1, then secant of x is just 1 over that, because it's the reciprocal. So it's 1 over 1, which is still 1. So anywhere on this graph of cosine that I get a value of 1, secant is also going to have a value of 1. So that means that all the places that already were 1, these points, these 3 peaks right here, are still going to be on the graph of secant. And then for whatever x value, if cosine of x is negative 1, then secant of x is going to be 1 over that. So 1 over negative 1, which is also negative 1. So anywhere on this graph where the value is negative 1 for cosine, it's also going to be negative 1 for secant. Okay, so then I think the most detailed analysis stuff that we have to do comes when we're approaching one of these asymptotes, or zeros for cosine. So let's look at what happens as I come in from this side towards pi over 2, right? So I want to figure out what happens to secant, right? So really what I'm doing is I want to see what's the limit as x goes to pi over 2 from, I'm on the left side here, of, well, let's look at what happens to secant, because that's really ultimately what we're trying to graph. Right. Well, I know that that's the limit as x goes to pi over 2 from the left of 1 over cosine x. And now if I take a look at what happens to cosine x when I get real close to pi over 2, but on the left side, well, it's really close to 0, but it's positive, right? So this thing right here is really like 1 over a really small positive number, right? Well, we know that that's basically infinity. So that means that as x gets close to pi over 2 on the left side, so from the left side here on this side of the asymptote, my y values are going to go to infinity. My secant values are going to go to infinity. So that means this is going to just shoot up to infinity like that. And then if you look at what happens, let's say, to the asymptote at negative pi over 2. Or actually, no, let's do pi over 2 from the right side instead. Right, so now we're coming in this way. Right, so if I look at what happens to secant of x, it's the limit as, I'm not really changing anything here. All I'm doing is turning secant into 1 over cosine. So if we look at what happens to cosine now, because that's all I really need to look at, what happens to cosine when I get close to pi over 2, but from this side, well, I get a really small but negative number. So it's 1 over a small negative number. And that's going to be the same thing as negative infinity. So right here, I'm going to shoot down to negative infinity. Let me make that folder there, down to negative infinity. And at that point, we can kind of see what's going to happen right here. As I get close to this one, also the cosine value is again getting really close to negative small number. So the secant value is going to be 1 over that, which also goes down to negative infinity. Similarly, over here on this side, as I get close to here, the cosine value gets close to a tiny positive number. So the secant value gets close to 1 over a tiny positive number. So then at this point, we've done one full period in this region right here. That's a full period because it goes 0 to 2 pi. And so it's just going to repeat everywhere after that and everywhere before it. So this red graph here is what you get for secant x. Yeah. If we scroll down here, I've also attached the cosecant one. But really, cosecant, it's based on sine, but sine is just cosine shifted over. So cosecant is just secant shifted over. And so I'm just going to jump right into this. I'm just going to draw my asymptotes at the zeros. And then anywhere that the original graph equaled 1, I know that my reciprocal is also going to equal 1. Anywhere that it was negative 1, I know that the reciprocal is going to be negative 1 anyway, because it's 1 over negative 1. When the reciprocal is 1 over, when the original sign is a really tiny positive number, the reciprocal is going to be a really big positive number. So it's going to do this. And whenever the sign value is a really tiny negative number, the reciprocal is going to be a really big negative number. Right? So we get a graph that looks an awful lot like secant, just shifted over a bit. Okay, hope that helps.